This is the question we want to solve. As usual, you can pause it and read it. So let's dive straight into it. Okay, from the question, we are given Q1, which is same as 8 times 10 raised to power minus 9 coulomb, and Q2 to be, which is same as 12 times 10 raised to power minus 9 coulomb. Now from the question, it says Q1 and Q2 are along the x-axis. So x-axis, y-axis. Q1 and Q2 are along the x-axis. Q1 was given to us on the x-axis along the origin, Q1. And it was given to us from point P. Point P, let's call this place P. For point P, 7 centimeters. It was 7 meters from the question, 7 meters. And Q2 was given to us along the x-axis. Q2 was given to us along the x-axis, 4 meters away from Q1. 4 meters away from Q1. 4 meters away from Q1. That means Q1 to point P, 7 meters. Q1 to Q2, 4 meters. That means from Q2 to point P will be what? 3 meters. So this is what we are given. So let's use this information to solve the electric field. Remember, electric field formula is given to us about K Q over what? R square. K is the constant of proportionality, Q is the charge, and R is the distance. Now, from the question, they gave us Q1 from point P 7 meters, Q2 from point P now 3 meters. Now, we want to calculate the net effect of Q1 on point P and the Q2 on point P. I repeat, we want to calculate the net effect of Q1 on point P and Q2 on point P. So this electric field formula will now be written as E equals to K Q1 over R is the distance. Q1 from point P is 7 meters plus K Q2, and Q2 from point P is 3 meters. So this will give us the net effect of the electric field on point P. So we impute our values. K is constant, which we know to be 9 times 10 raised to power 9 times Q1, which is this, 8 times 10 raised to power minus 9, all over 7 square, which is 49, plus K, which is 9 times 10 raised to power 9, multiplied by Q2, which is 12 times 10 raised to power minus 9, over 3 square, which is what? 9. This is 10 raised to power 9, and this is 10 raised to power minus 9. So this plus 9 can cancel this, remaining 9 and 8. 9 multiplied by 8, 72. 72 divided by 49 will be 1.4, approximately 1.47, plus this same thing here, plus 9 minus 9, so these two can go. 9 multiplied by 12, 108, divided by 9 will be 108 divided by 9, that would be 12. If I'm not mistaken, that would be 12. So this plus this electric field will now be 13 plus 47 nano per coulomb. This is the net effect of Q1 and Q2 on point P. Why the part B of same question, let's repeat. Q1 was given to us from the origin, Q1, Q2, 4 centimeter apart, 4 meters. Don't know why I like using centimeter, 4 meter apart. Now, this time around, the question says, let's calculate the net effect on point Q. And Q was given to us along the y-axis. Let's call this place point. Let's call this one Q. And from the question, from Q1, the charge Q1 to point Q is given to us as 3 meters. Now, the problem here, we know the distance from Q1 to point Q. What about Q2 to point Q? What about Q2 to point Q? So, for us to get Q1, the distance from Q2 to point Q, we join here to here. So Q2 to point Q, what is now the distance? From previous knowledge of Pythagoras theorem, here this is a right angle triangle. So if you are given here to be 4 meters, here to be 3 meters, to get the long side of a right angle triangle, applying Pythagoras theorem from your basic knowledge, let's say hypotenuse square equals to adjacent square plus opposite square. The adjacent here, 3 square plus opposite here, 4 square, which is 9 plus 16, which is 25. So hypotenuse square is 25. So hypotenuse is equals to the square root of 25, which is equals to what? 5. So the distance of Q2 to point Q is 5 meters. After getting this information, so what we have to calculate the net effect of Q1 on point Q and Q2 on point Q. Just like the way we did for when all of them were along the x-axis. The net effect of Q1 on point P and Q2 on point P. But this time around is the net effect of Q1 on point Q, Q2 on point Q. So we dive straight into it. Okay, as we continue, we want to calculate the electric field of Q1 from point Q. So let's calculate the first one. Let's call the first electric field E1, which is Q1 over R square. As we all know, K is 9 times 10 raised to power 9. Q1 is 8 times 10 raised to power minus 9 all over R, which is the distance. R, the distance is 3. So 3 square. So E1, we get again, this is 10 raised to power plus 9, 10 raised to power minus 9. This can go. 9 times 8 is 72, divided by 9 is 8. Okay, in other words, 3 times 3 is 9, 3 times 3 is 9, 9 cancel 9, so remaining what? 8. So this is 8 Newton per coulomb. We have done, we have calculated the Q1 at point Q, then want to calculate Q2 at point Q. Let's call that one E2. So similarly, KQ2 over R square, which is 9 times 10 raised to power 9 times Q2, which is 12 times 10 raised to power minus 9 over, what is R square again? 5. So 5 squared. So E2 is equals to, let's do the mathematics. This can go 9 times 12 is 108. 5 square is 25. 108 divided by 9 times 12. That should be 4.32 Newton per coulomb. But this is not the final answer. Why? Because we have calculated for Q1 to this, which is this. We are to resolve this one because this, how will you define this? Is this vertical or horizontal? Is it vertical or horizontal? You cannot give this line vertical or horizontal. So you have to resolve this line into vertical and horizontal. How do we do that? We want to resolve this into both the vertical column, vertical axis, and what? Horizontal axis. So let's start with the horizontal axis, which is the x-axis. Resolving it into the x-axis, x direction, resolving it into the x direction, our electric field will be E2 sine theta. Resolving this into the horizontal, will have E2 sine theta. We have done this E2 before. E2, what is E2? 4.32 multiplied by sine theta. What is sine theta? Let's look at the diagram again. Sine theta, sine theta simply means opposite over hypotenuse. And what is the opposite here? 4. Hypotenuse is what? 5. So sine theta is 4 over 5. So replace that. 4 over 5. This is 4 over 5, which is 0.8. So sine theta is 0.8. If we resolve that, we will get 4.32 times 0.8. We'll get, let's do it, this. We'll get approximately 3.46 Newton per coulomb. Recall that this E that we have gotten, we have resolved it in the what? X direction. So we are also to resolve this in the Y direction. Resolving it in the Y direction, we have EY equals to E1 plus E2 cos theta. Now I know you will ask me, why resolving it in the Y direction? Why do you have E1 plus E2 cos theta? Now, this is resolving it. E2 cos theta is resolving it into the Y direction. But we already have a value for Y direction, which is E1. We have calculated for E1 before. This one is also in Y direction. We are resolving this one into Y direction as well. So we have both E1 and this one that we are resolve it into the what? Y direction. We already have E1 in the Y direction, so we are resolving this part into the Y direction as well. So we have these two will give us the total in the what? Y direction. So we have, what is E1? 8 plus E2, okay, 4.32 cos theta. Now, what is cos theta? Let's look at the diagram again. Cos theta is adjacent over hypotenuse. Adjacent 3 over 5. So cos theta is 3 over 5. And 3 over 5 is 0.6. So if we replace this by 0.6, we'll have 8 plus 432 times 0.6. So resolving this, we'll have 4.32 times 0.6. So we have 8 plus 2.592 plus this plus 8, which is 10.592. So the electric field in the Y direction is 10.592 Newton per coulomb. Finally, now, what is the net effect of Q1 at point Q, Q2 at point Q, resolving the resultant field at point Q? So let's see. The resultant field at point Q will be, the resultant field at point Q is equals to the square root of EX plus EY, because we have resolved it in the X and Y direction. So EX is minus 3.46 all square. Okay, sorry, I forgot the square. EX square, EY square. Now, when we got this, I omitted the minus sign. Why? Why? In our solving, we omitted the minus sign. Why? Because you are resolving this in the X, we are resolved this in the X direction, but resolving it, the X direction was going backward. So backward means minus, forward means plus. So that is why I put the word minus. So you can correct your correct that your previous answer, put the minus, because you are calculating the X direction backward. So backward, you put what? A negative sign. So let's go. Minus 3.46 plus EY. What is EY again? 10 point, let's just approximate it, 0.6 square. If you do this, let's say this, 3.46 square will have approximate, minus will give us plus, we have 11.97 plus 10.6 square. This will give us 11.36. So This plus this, let's go, plus 11.97. This will give us the square root of 124.33. So the square root of this will give us 11.15 approximately Newton per coulomb. So this is the net effect of Q1 and Q2 on point Q. Thank you.